Hello everyone, we're from Group 5 and we're going to discuss the relation of water rocket and physics. And our group consists me, Daphne, Isabelle, Angel, Viona, and Catrina. And now we're going to start our discussion.
The topics we're going to talk about is the first one is about to get to know water rocket. The second one is about physics concept of water rocket. The third one is principle of water rocket according to physics, and the last one is about tips of succeeding the water rocket according to physics.
So first is about get to know water rocket. Water rocket is simply a rocket that uses water as its fuel. The pressure vessel that functions as a rocket engine is usually made from used plastic soft drink barrels. Water is forced out by compressed air. So this is the illustration of the water rocket. There's like nozzle on the bottom, garden hose, quick connector, and then there's soda bottle. And then the white part is the compressed air, and then the blue part is water and the fins. Okay, so the recommended shape for the fins are trapezium because it makes further glide distance. Also, the top of the water rocket has to be cone shaped so it reduces friction with the air and the water rocket can go faster. Get to know water rocket. The basic theory of launching a water rocket is the same as the balloon experiment that slides up. First, water rocket gives a big amount of action force to the gas by pushing the gas out, and the gas gives the same amount of action force by pushing the water rocket upwards. Second, the thrust exerted by the gas on the water rocket is the same as the force exerted by the water rocket on the gas, only in the opposite direction. Third, the water rocket pushes the gas down and the gas pushes the water rocket up.
The second topic of our presentation is about the physics concept of water rocket. Brief explanation of physics concept. We start with the third Newton's law. The second one is about momentum and impulse. The third one is about the parabolic motion, and the last one is about Bernoulli's principle.
So the first concept is Newton's third law. Newton's third law statement is when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. And the formula for Newton's third law is force action is equal minus force reaction. And this is the illustration. So the next one is momentum and impulse. Momentum is rho. It's a measurement of mass in motion. How much motion is usually given the symbol rho. Rho equals to mass times velocity. Impulse is the measurement of how much the force changes the momentum of an object. In order to make an object move, it is necessary to exert a force on it over a certain time interval. The formulation of impulse is I equal to force times delta time. Force, the greater the value of the mass and acceleration of the water coming out of the nozzle, the greater the F value in impulsivity. Assume that the impulse value is constant. So the greater the F's value, the smaller the T's value. The greater the force F that is applied to the rocket, the faster the rocket moves. The third physics concept in water rocket is parabolic motion. Parabolic motion is a form of motion experienced by an object that is projected in a gravitational field, such as from Earth's surface, and moves along curved path under the action of gravity only. The formula for parabolic motion is maximum horizontal range equals object's initial speed square times sin 2 times elevation angle or alpha divided by gravity.
The last one is about the Bernoulli's principle. So, in fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. The principle is named after Daniel Bernoulli, a Swiss mathematician who published it in 1738 in his book Hydrodynamics.
So the third topic is about principle of water rocket according to physics. So the first one is Bernoulli's principle, and the second one is momentum and impulse. Third is third Newton's law, and the last one is parabolic motion.
This is the first principle happen, Bernoulli's principle. Bernoulli principle happen when cross-sectional area in the pump and the water rocket nozzle have the same speed, even though they have wide differences.
Second principle happen is Newton's third law. Newton's third law happen when rocket and the surface under have an action-reaction. The action force of the air and water as it rushes out of the nozzle creates an equal and opposite reaction force propelling the rocket upward. So, the action is from air and water from their direction makes the rocket upwards.
The third principle happen is momentum and impulse. There are two principles happen at the same time when the rocket take off, which is momentum and impulse. When force were given to water rocket and the moments before water rocket take off called impulse. Meanwhile, the movement from it take off to landing on the water rocket called momentum.
And the fourth principle happen is parabolic motion. Water rocket that moves after the impulse momentum has a parabolic shape as shown in the slide. So this is the illustration when the rocket take off and land and creates parabolic motion.
Tips of succeeding the water rocket according to physics. The first one is degree effect, the second one is precise diameter, the third one is preventing bottleneck. As we can see on the slide, degree level really affect the height and how far the water rocket can go. For 75 degree, rocket can fly high, but the range is short. For 60 degree, the rocket fly, but not as high as the 75 degree. The range is further than 75 degree. The 45 degree is not that high, but has the furthest range. And 30 degree has a short range and low height. In accordance with the formula XA equals to VO squared sin 2A divided by gravity when the degree is 45, then sin will be 90, where sin 90 will be 1. So when the rocket is directed 45 degrees, the rocket will reach the furthest distance.
Precise diameter. The making of nozzle diameter has to be precise because the bigger the diameter on the rocket's bottom, the greater the water's mass and pressure. But the water velocity will be slower. Meanwhile, the smaller the nozzle's diameter, the faster the water's velocity and the weaker the pressure, because the pressure and diameter is directly proportional, while diameter and velocity is inversely proportional.
The last tip is to preventing bottleneck. Bottleneck happen when there's a sudden change on the nozzle's diameter. The nozzle will become smaller and cause that flow in the water way out, whereas the flow of the water take part as a source of kinetic energy for the rocket when it releases. Every bottleneck occurrences can be prevented by not making the nozzle's diameter too small.
And these are the experiments videos about water rocket that we put. Hopefully it can help you to understand more about water rocket. So that's all from us. Thank you for listening.
And if you have any question, you can contact us. So this is what the simulation looks like if we actually make water rocket. So we have to do this. So we have to make this 45 degree so it get the furthest range.